All right, ladies and gentlemen, so this is quiz number 3 out of the book. And the first question here, 3.2, is to consider the following card game with a well-shuffled deck of cards. So you assume that the deck of cards is going to be completely at random. If you get a spade, you win $5. For any club, you win $10, plus an extra $20 for the ace of clubs. Create a probability model for the amount you win at this game. Also find the expected winnings for a single game and the standard deviation of the winnings. So this one was a little bit complicated, right? Because you have to take into account everything that was going to happen. And so the way that we lay this out is event. You get a red card, right? If you draw a red card, you get nothing. All right. If you get a spade, you get $5. For any club, you get $10 plus an extra $20 for the ace of clubs. And for this, you need to understand how cards go. So the number here, or the payout here, is X. So you get nothing for the red. You get $5 here. You get $10 here. You get $30 here, right? Because 10 and 20, the extra 20 is 30. What is the probability of X? Well, probability of getting a red card is 26 out of 52, or 1/2. The probability of a spade is 13 out of 52. There's only 13 spades in there. The probability of a club is 12 out of 52. And the probability of the ace of clubs is only 1 out of 52. There's only one ace of clubs in there. So then you multiply these two. X times the probability of X, and you get 0 right here. You get 1.25 here, because remember you're multiplying across. You get 2.31 here, and you get 0.58 here. So all things being random, the most amount of money that you would get just by random chance alone would probably be around, and I'm saying probably, this is a mean, at 4.14, or the expected. This is what you expect. So then X minus the expected, and because the expected could be more than the X, we need to then square this to get a positive number. So this is 17.14, 0.74, 34.34, and 668.74. And then an even bigger one is this times the probability of X, which is all the way over here, and it gives us 8.57, 0.18, 7.9, 2, and 12.9. Okay? And so you sum this up and you get the variance, which is 29.54, and the square root of the variance is the standard deviation, which is 5.435. So this is part A. You created the probability model. So now what is the maximum amount you would be willing to play this game? And so here, I already kind of hinted at it, is that just by random chance you'll get 414. So that's, the maximum amount that you would play. So you get everything back. Obviously you can get 0, or you can get a whole bunch of money. But this is right here. If you want a good answer, it's not the right answer or wrong answer, as long as you explain your reasoning. But my reasoning would be, this is what I will get just by chance on the average and in the long run. So that's how much I'm willing to put in, so that I don't end up losing. All right. So here we have another question 3.4, which is again another probability model, just like we did. So no baggage, 1 bag, and 2 bags, and we have 0, 25, and 60, and the probability of X, 0.54, right? That 4 looks like a 6, 0.54, 0.34, 0.12. And then we multiply them across, right? So that gives us x of p times x times p, 0, because 0 times anything is 0, 8.5, 7.2, and our expected 1570. Okay. So that is our average right there. Average revenue per passenger will be about that right here. Corresponding standard deviation, x minus e of x, and then we got to square it all because sometimes we might get a negative. So this is 246.49, 86.49, 19262.49. Sorry, 1962.49. And then we then take that and multiply it times probability of x to get the variances: 133.10, 29.41, 235.5. So the variance of x is equal to 398.01, and the square root of that is 1995. Okay. So that answers all that. About how much revenue should the airline expect for a flight of 120 passengers? Right? So you could do 120 passengers times 1570, because that's your expected. If all things being equal, that's what you would do. And then you could add up the variance, right? If you add up the variance for all 120 passengers, it would be something like 120 times 398.01, which is like $47,761. And then the standard deviation is the square root of that, 218.54. So you can tell people, you can tell the airline, if everything is equal, you'll get 1884. If it's normally distributed, you'll get 1884. But you can have, your standard deviations. You could go above or below that by the standard deviation. All right, the next question: chickenpox. The National Vaccine Information Center estimates that 90% of Americans have had chickenpox by the time they reach adulthood. Okay, so chickenpox. NVIC, by the way, NVIC, it's an anti-vaccine organization. We're going to have to fix this. They're not to be believed. But anyways, let's just say, for the sake of argument, that 90% of Americans have had chickenpox by the time they reach adulthood. This is one of their arguments, that, chickenpox is survivable because we've all had it and we've all survived it, so it must not be a big deal. Don't get me started. Okay, so let's go to the okay, suppose we take a random sample of 100 American adults. Is the use of the binomial distribution appropriate for calculating the probability that exactly 97 out of 100 randomly sampled American adults had chickenpox? So we got to make sure that they're independent trials, right? Independent. That we have a fixed number of trials, in this case 100, right? Because we're pulling 100 people. That there's only two outcomes. You either had it, yes, or no. That makes it binomial. And then the probability of success is the same for each trial, 90%, right? And so if it fits these four things, then yes, we can use the binomial distribution. For the second question, the probability that exactly 97, so probability that exactly 97 people have it, you just plug in your formulas that you have there in the book, and how many combinations there, times your probability, raised to the exponent of 97, times the probability of not, 3 out of not. And so your probability is 0.059, or 0.59%. So So that is B. C. What is the probability that exactly 3, right? That exactly 3 out of a new sample have not had it? Well, it's already here for you guys. It's the same thing. Because remember, the probability didn't change from one trial to the other. So it's right there. Okay? It's the same. The birthday problem is one of those things too. What is the probability of 2 people having the same birthday in a group? It's the same as the probability of the total number of the group minus those 2 people not having their birthday. Okay, and then so that's C, and then D. The probability that at least 1 out of 10 randomly sampled American adults have had chickenpox. All right, so for that we're going to probability that at least 1, more than 1, have had chickenpox. And so it's the probability of X equals 1 plus the probability of X, the probability of X equals 2, and so on and so forth, all the way to the probability of X equals 10, right? 1 out of 10. And so it's also 1 minus the probability of X equals 0, right? Because we didn't include X equals 0 here, so it's the complement of that. And so it's about 1. So, because this is 1 minus 0.10 raised to the 10. So it's still close to 1, because this is a really, really tiny number. Okay, so it's almost certain that 1 out of 10 randomly sampled American adults will have had chickenpox. What is the probability that at most 3 out of 10 randomly sampled did not have chickenpox? Or P is less than or equal to 3. The probability of X. So here we're working on E. The probability of X less than or equal to 3 is the probability of X equals 0 plus the probability of X equals 1 plus the probability of X equals 2 plus the probability of X equals 3. It's a little tedious, but this is how you come up with the formula eventually. And then you just do all the math there, right? For 1, you're gonna use this formula up here, but for 1 it's 10, 0, and then everything, and then 10, 1, and then everything. You're gonna add it all up, and it adds up to 98.72%. Okay, so that's that. Okay, question 3.10. Again, don't trust NVIC for statistics, please. Do not do it. CDC, NIH, George Mason University, Johns Hopkins University, anything but that. But enough about that. You can see that I'm a little hung up on it. So we now consider a random sample of 120 American adults and still the 90%, right? How many people in the sample would you expect to have had chickenpox in their childhood, and with what standard deviation? And so here you have to know the formula for the mean, which is equals to N and P, and the standard deviation, and so that is the square root of N, P, 1 minus P, right? And so what is N? Is 120, and what is P? 0.9. And then you just plug it in, right? 120 times 0.9, that's your mean. That's how many you would expect. And what standard deviation? Then you do the rest of it, and it's 3.29, and this is 108. So that's easy peasy. Just know the formula, know when to apply it. We're talking about binomial, right? We're talking about yes and no. We're talking about independent trials. Just because somebody had chickenpox doesn't mean that the next person will, which it's an infectious disease. And so on and so forth. Just know those 4 rules, okay? That's a big hint for the midterm. B is, would you be surprised if there were 105 people who have had chickenpox in their lifetime? And so here, you're going to do a standardization, Z. You're going to do Z equals 105 minus 108 over 3.29, which is a negative number, right? Because we right off the bat up here, it's telling us it's going to be negative 0.91. Since 105 is less than 2 standard deviations away from the mean, we wouldn't consider this to be an unusual observation or be surprised. There's actually a pretty good chance that that this is the case. And this is why we do standardization. Remember, guys, because we want to see how far away from the mean something is on the standard scale. Okay, and then C, what is the probability that 105 or fewer people in this sample have had chickenpox in their childhood? You do the formula again, knowing that P, X, 105 or fewer, 105, right? And then you just go P of X equals 0 plus all the way over, right? It's tedious. It's a lot to do, and so let's just do the Z, right? So we do it this way. We say the probability of X less than 105 plus 0.5, because remember we need to correct for the binomial, is equal to probability of X less than 105.5, which is equal to the probability of Z being less than 105.5 minus the mean 108 over the standard deviation or the standard error, however you want to call it, is equal to P Z less than 0.76, but because it's a negative up here, you're going to put a negative in front of there, and you look at the tables, and your probability is 22%, 22.36%. All right, and this is an equal, not a parentheses. So as you can see, we use the approximation, binomial approximation to the normal distribution here to answer that question. The next question here, while it is often assumed that the probabilities of having a boy or girl are the same, the actual probability of having a boy is slightly higher, 0.51. Suppose a couple plans to have 3 kids. Use the binomial model to calculate the probability that 2 of them will be boys. Okay, so the binomial model, the n is equal to 3, your p is equal to 0.51, and then you plug it into the formula. The probability of x equal to 2. The 2 boys is combinations of 302 times 0.51 squared times 0.49, which is equal to 0.3823. All right, so that's your probability that 2 of them will be boys for B. Write out all the possible orderings of 3 children, 2 of whom are boys. So you have boy, boy, girl, boy, girl, boy, girl, boy, boy. That's the possible combinations. And the probability that 2 of the 3 are boys, so it's the sum of the probability of these 3 orders, right? So it's 0.51 for the first one, it's a boy, times 0.51 for the second one, it's a boy, 0.49, it's a girl, 0.12744. You notice that these are the same here and here, so you just have the same probability. It's just different order. Okay? And so then the probability that 2 of the 3 are boys is all these put together. 0.3823, which was the same question up here. You just have to work it out in a different way. And so now, for C, if we wanted to calculate the probability that a couple who plans to have 8 kids, my goodness, plans to have 8 kids will have 3 boys. Briefly describe the approach from part B would be more tedious than the approach for part A. So then, yeah, this is, how many combinations to get 3 boys out of the 8, right? So you have boy, 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 followed by 5 girls. Then you have boy, girl, boy, and then girl, 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 boy. And so on down the line, you get 56 scenarios. And then you'd have to figure out, you would have to get the probability of each the probability of each and multiply it times 56, like we did up here, it's tedious. So it's better to just use the binomial approximation, binomial distribution. It's super easy. You just plug it in, right? What would that be? It would be just 3 times 0.51, and you would have 3 boys, right, times 0.49 and 5 girls. Did I do that right? I think so. Yep. And then you get the answer. All right. All right, so my biostats professor used to say, when in doubt, draw it out. And so we are going to draw the z-score for A here. I'm going to use black for my normal distribution. Remember that z at the mean here is 0. And let's see, negative 1.13 would be like right here, right? And so we would draw it like this, and we're asking greater than 1.13. So what is the probability of a z-score on this side, right? And so you can look at the z tables and find negative 1.13, which would give you this area over here from a z table. But if we know that the whole thing is 1, then you just do 1 minus what the probability you see in the z table for the left. Although there's some z tables I can tell you probability to the right, but 1 minus that will give you the red area here. Or you can go to R, and in R, you just do, for this, for the blue area in R, you would do P norm negative 1.13, and to calculate the area in red, you would do 1 minus P norm negative 1.13, which in this case is about 87%. Okay, that's what you would get in R. So you can do the tables, you can do R, you can do an online calculator if that's what works for you. I consider this to be a lot like reading a map. I can teach you how to read a map, and you can read it. But nowadays, you can also go to Google Maps. But if you're really interested in figuring out how maps work, then yes, go learn how to read a map. If you just need to use a map for quick things, then go to Google Maps. So if you need to do math real quick, use a calculator. Understand the math that goes behind it, and in case you get something weird, right? Because this is obviously here we have 87%. It makes sense, right? It's more than 50. But if you were to get over here 87%, that would not make sense, and be aware of that, right? So let's do the next one. I'm just going to do the first couple of ones here for you guys, and then you guys can do the other ones on your own. Again, when in doubt, draw it out. 0.18, so that's very close right here, right? 0.18, it's to the left. So the question here is, what is this area in red here, right? And like I said, or actually, let's go ahead and do it in blue to keep it consistently with the other one. So you would just do P norm 0.18, which comes out to be about 57%. Okay, and it makes sense because it's more than 50, it's more than 0, so it's got to be more than 50%, and then just a little bit more right there. All right, and so everything to the right over here would be 1 minus 0.57, or about 43%. Okay, and you guys can do these. For this one, the absolute value of z. All right. So what is the absolute value of that? So for that one, let me just draw it out for you. It's 50, right? 0.5, so 0.5 right there. And what is the absolute value? don't forget, we're talking about the absolute value of z. So 0.5 and negative 0.5. So we're talking about two different areas, and take that into account. Okay, so you should get a range there that is between this percentage here to this percentage over here. All right. Okay, so I want to apologize. The toddler has turned on her eye device in the background, and she's watching cartoons. So you might hear that. So here we're told that the finishing time in men has a mean. So we're going to say x mean, xm for men, 43. Sorry, there goes my dyslexia again. 4313 seconds with a standard deviation in men of 583 seconds. The finishing times for women is 5261 with a standard deviation in women of 807 seconds. Okay? If a man finishes the race in 49:48 seconds, what percent of triathletes in the group did he finish faster than? Note that the better performance corresponds to a faster finish. Okay, so that kind of flips things on its side. We're going to have to be looking at the left-hand side of the curve, right? Because lower is better in this case. So we know that for men, the z-score of 0 corresponds to a mean of 4313. And then we know that for women, the c-score of 0, and I apologize for my terrible handwriting, I'm holding the tablet up in the air, corresponds to 5261. Okay? So if a man finishes at 49:48, right, so that's 49:48, the question is, what percent of triathletes in the group did he finish faster than? So remember, to the left is better, so people are going to be faster than him to the left. So we're asking, what is this area here? Okay? So we need to know the z-score, and we need to know that area. And from the z-score tables, we can calculate this area over here. And we know that 1 minus the blue will equal the red. And how do we calculate that z-score? We do 4948 minus 4313 divided by 583, and that is our z-score. And then we just plug it in. We look for the probability for that z-score for the blue, and then we do that calculation. So I'll leave that up to you guys because I don't have my calculator with me right now, and it's just math. Okay, if a woman finishes 5513, so she finishes 5513, and let's do this in red to be consistent. 5513. What percent of triathletes in the group did she finish faster than? Right, remember again, we want to know this side. Lower is better, so people with more seconds are slower than her. Right? Okay. So now you know where we're going with this. We're trying to figure out the blue area here as well. And just like with the men, we're going to do 5513 minus 5261 divided by 807. And that is our z-score here. And then we do the same thing. We look for the probability to the left. 1 minus that is the red. Calculate the cutoff time for at least 5% of athletes in the men's group. Excuse me. So we are the fastest 5% are going to be over here, right, in the left, because they're lower times faster. Z-score of 0, but we know that the corresponding is 4313. So we want to know what this Z is. so that it's going to be a negative. So something minus 4313 over 583 is equal to the z-score that corresponds to 5% to the left. All right, and you just go find that in the tables and then plug it in. You do the same for the slowest 10 in the females. When in doubt, draw it out. And here, the slowest 10 is going to be over here. So you find whatever corresponds to 10%, 5% over here, by the way. Again, same thing, 5, 2, 6, 1. More seconds, slower, right? So you calculate the z-score for 90% in this case is equal to something minus 5261 divided by 807. Solve for x, and then that is your z-score. Okay, so that's how you do this problem. For this problem, the way you're gonna work this problem is normally distributed, mean 3.2, standard deviation 1.5. What is the middle 95%? And for the 95% in here, it's from negative 1.96 to positive 1.96. So you have to do two operations here, right? Negative 1.96 is equal to something that you're solving for minus 3.2 divided by 1.5, solve for x. And that is your lower end. Your upper end is 1.96 is equal to x plus 3.2 over 1.5. Why am I not solving this? Not only because I don't have my calculator in the z-score table, it's also because, big hint, for the midterm. Okay, learn how to do this. Learn about the rule of 1 standard deviation, 2 standard deviations, or 1.96 in this case, and then 3 standard deviations. All right, what's between 3 standard deviations? What's between 1? And in this case, 1.96. So this is your lower end, and this is your upper end. Okay, and then your range is just going to be XL to XU. All right. This one is also a hint for the midterm. So let's do A first. IQ's in the top 2% of the population. Okay, so we know it's up over here, the 2%. We know that the rest over here is 98%. We know that IQ of 100 is the mean. And we know that the minimum score required for admission is 132. Right? So we're going to solve for Z, 132 minus 100 divided by the standard deviation, which is what we're looking for. Right? And then we get the Z of 98% from the table, and we just solve for the standard deviation. When in doubt, draw it out so you can understand what's going on here. Okay? For B, cholesterol levels for women approximately normal with a mean of 185. Women with cholesterol levels of above 220 are considered to have high cholesterol, and about 18.5% of those women fall in that category. So like you did in the other ones, you're gonna try to figure out the z-score for 100 minus 18.5 is going to be equal to 220 minus 185 over the standard deviation. All right, and so figure that out, and you can figure this out. Again, hint for the midterm. All right, back to the don't use the National Vaccine Information Center for references. I already contacted the authors of the book, and they were not happy. They didn't know what went on. But anyways, question number 1. A random sample of 120 American adults, and the probability is 90%. How many people in the sample would be expected to have had chickenpox in their childhood with what standard deviation? This is the N times P. So we know that the mean is equal to NP. We know that the variance is equal to NPQ. And we know that the standard deviation is just the square root of the variance. Okay? And so Q in this case is 0.1. Don't use the percentages in math. So you have what you need here, right? So you have normally distributed, right? About 90% there. I don't even know if you need to do this drawing out. I mean, I know, I don't even think you need to do this drawing out, but just so you can visualize it. And so, how many people in the sample would be expected to have had chickenpox in their childhood? Or what standard deviation? So here's your standard deviation, right? And N times P is your expected. So you're good. That's all you need to do. I don't even know why I was doing this. Evaluate the conditions for using the normal approximation to the binomial. What is the probability that 105 or fewer people in the sample have had chickenpox in their childhood? So for the second part, remember that you need to use the continuity correction, right? So they're asking us the probability that less than 100 or 5, but we also need to do the continuity correction. Okay? So you do that by taking out 1/2. And you look up that in your and you do your diagram here. And again, your mean N times P. And your standard deviation, you have it square root of NPQ. So your mean NP 105. Sorry, 104.5. And then you get your z-score that'll go right here because it's negative, right? 105 is to the, well, is it 120 times 0.9 0 108. So this is 108. Yeah, so it's on the left-hand side. So this will be 105. Intuitively, I kind of knew. 105, and so then you just do the math, right? 104, 108, you put it in here, and then you get the z-score, corresponding z-score, and then the probability then you're looking for is what is the area under the curve here. And remember, I showed you how to do that in a previous slide in R. Right, right here. All right, and that's it. If you have any questions, comments, put them in the discussion forum, email me. Let's get together this Friday and go over the midterm prep. I know that you have to do module. I can do some really good M's. Module number 4. It's due on Sunday. I will post the how-to video Sunday night. As soon as I see that if everybody turns it in early, then it gets posted early. If not, I'll post it Sunday night after midnight, or Monday morning, first thing in the morning. So you can take a look at that before you work on the midterm, because I want you guys to know the answers to your module number 4, so you can use that, because hint, 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 there's a couple of questions in the midterm that come off module number 4. With that, thank you so much. Don't forget to look everything over, re-watch the video if you have to, and ask me any questions if you need to. Thank you.